Okay, we've done, in chapter 5, we did like area underneath a curve. We did it by rectangles, we did it by trapezoids, we did it by the parabolic arcs, Simpson's method, and then we did figuring the antiderivatives. We also did the second function calculate on figuring the integrals on the calculator. When we did that in the last chapter, it was basically, if I figured something like this and I said, find the area underneath this curve, but it was bounded by the x and y axis. Okay, now in this first section, what we're going to do is I'm going to give you and say, okay, here's a curve, here's another curve, now find the area between those two curves. Okay, you're not going to have the vertical and horizontal lines. Okay, that's what we're going to do in 6.1. Areas between curves. Okay, in 6.1. Then we're going to start doing volumes where you take the curves and then actually rotate those curves about an x or a y axis and figure volume instead of area. Okay, so today is going to start 6.1 on areas between curves. Okay. And we're going to add formulas to the card here in a minute. I'll tell you at the end what I want you to add. Okay. And these I'm going to show you basically two examples. I'm going to talk you through two examples. And it will just say find the area. Okay, so find the area between the curves y equals x to the fourth and y equals 2x minus x squared. Okay, and that's basically all they give you. Okay, first thing you want to do is get a picture. Okay, so on your calculator, let's graph. And I'm actually going to give you a window that'll make this look better. In y sub 1, let's put in the, and I'm doing this one on purpose. I want 2x minus x squared in y sub 1. In y sub 2, put in x to the fourth, and it's actually going to look like, remember you have to use that caret symbol, x to the fourth. Okay, and the window I want you to use for your x min, use -1. For your x max, we're going to zoom in quite a bit on this. For your x max, do 2, x scale of 1. For your y, do -1 to 2 and scale 1. Okay. We'll take a minute and put that in. One thing I would do, and when you set your window, graph that first one so you see what it looks like. Okay, so if you sketch the first one is a parabola that opens down. And remember, you can tell it's a parabola because it's an x squared. You can tell it opens down because it's a negative sign in front. Okay, and it should be going like from 0, and we'll have to check over here. It looks like 2, but we need to check it. Okay, and for right now, then graph the in y sub 2. Put in the x to the fourth. Graph that one. Okay, and remember that still kind of looks like a parabola, but if it's an x to the fourth, if it's even, remember it's going to be a little bit flatter down here at the bottom, so a little bit flatter. Oops, hang on, I didn't draw that very good, hang on. something like that. So I would label this one is the y equals x to the fourth. This one is the y equals 2x minus x squared. No, I labeled the same one, sorry. This one is the y equals 2x minus x squared. So it opens down. Okay. Now what we're trying to find is what's this area in between? What's that amount to? Okay. On the formula for these, we're going to do the integral. Okay. The area equals the integral of f of x. It's f sub 1 of x minus our second function f sub 2 of x. Okay, and put a bracket around that. Okay, and it's with respect to x. Now, this is the critical part of this. Okay, the first one, and I would highlight it or star it. It's the upper graph. That's why it's important that you label them. Okay, and then you're going to subtract the lower graph, the lower curve. Okay, that's probably the most critical part about this. Okay, so then the area equals the integral, and when you're doing this, you're actually figuring vertical slices. If you do the vertical slices on this, everywhere you do a vertical slice, the top curve is always 2x minus x squared, and the bottom curve is always the x to the fourth. Okay? So if we do the upper curve is the 2x minus x squared, minus the lower curve is the x to the fourth. And then with respect to x. Now, the a and the b, if you integrate and do vertical slices with respect to x, you're going to use the x value of the ordered pair where it intersects. So, you can do second function calculate, but you can also do that's going to end up going through 0, 0. If you did second function calculate, then you can do intersect. Hang on, intersect. Spell it right. And you can figure this ordered pair is the ordered pair 1, 1. Okay? When you integrate with respect to x, okay, like I just said, you're going to use the x values. Highlight this one and highlight this one. Okay? So the ordered pairs over here that you're going to use are from 0 to 1. Okay, you're finding the area from this x value to this x value. Okay? With me so far? Okay, so now we do the antiderivative, okay, like we've done in the past. Okay, we can't combine it. If you can combine any like terms, right there you do it, okay, because that'll make it easier. Instead of having 2 or 3 terms, if they're all x cubes, add them together, okay? Okay, so on this one, add 1 to this exponent, divide by the new exponent, okay? Add 1 to this exponent, make that x cubed over 3, divide by the new exponent, and add 1 be the x to the 5th divided by 5. Okay? You can reduce, the 2's will divide out, those will reduce to 1. Okay, and we're going to evaluate it from 0 to 1. So you're going to sub in the top number first. Okay? And if you sub that in, you're going to have 1 squared minus 1 cubed over 3 minus 1 to the 5th over 5. And then if you sub 0 in, aren't they all going to drop out? Because we'd have 0 minus 0 over 3 and minus 0 to the 5th over 5. So that's all going to drop out. Okay, so if you simplify that, that'd just be 1 minus 1/3 minus 1/5 common denominator. 15? All right, so you'd have 15 over 15 minus, you'd have to multiply this by 5, multiply this by 5, multiply this by 3, multiply this by 3. So you end up with 7/15 for your final answer. You agree with my arithmetic? Okay. Now, to check this on the calculator, okay, if we're going to go on the calculator to check it, we're going to do it in the immediate mode first. In the immediate mode, I want you to use the FNINT, the function integral. Okay, and the order that you write it makes a difference. I want the upper curve was y sub 1 minus the lower curve was y sub 2, and then comma x. You have to put in your variable, and then we're going to go from 0. We want the area from 0 to 1. Okay, so let's do that. In the home screen, do FNINT, that's math. What was it, math 9? Yep, math 9, and then the vars key, right arrow over to y variables, function, pick up y sub 1, minus, and then the vars, right arrow over to y variables, function, go down and pick up y sub 2, and then comma, remember that's above the number 7, and then x, comma, 0, comma, 1. Okay, and remember if you go 3 decimal places, we'd be at 0.467. Remember, if they don't come out even, go 3 decimal places. So check that. Take 7 divided by 15. Okay, we should get to 0.4667. 467. Okay. Okay. Now another thing you can do on your calculator. We might have done a little bit of this. I don't remember. I want to actually shade that area. In this graph, I want to actually shade this so you can see it shaded. Okay. And a calc teacher could say, I want to see it with the vertical slices. Okay. So you use the keyword shade. Okay. And you shade. Oh, by the way, up here you might want to say this is the upper one minus the lower one. The order that you do this makes a difference. Okay, and on the shade, you actually go shade above this. So it's y sub 2, comma, and below, shade below. So the order makes a difference there. And then comma, and you're going to go from 0 to 1. And then this number can be a 1. This number can be a 1 through 4. Okay? 1 is vertical. If you put a 2 in there, it's horizontal. If you put a 3 in there, it's going to do a negative 45 degrees, so it would go this way, negative 45. If you put a 4 in there, it's going to go a positive 45. Okay, we're going to use 1 for vertical slices. And then you need one more number, and that number, I'm using 5. That number can be 1 through 8. And if I'm using 5, I'm saying skip to every 5th pixel. Okay, so in the home screen, go back, second function, quit. Okay, shade is under the draw menu. You guys have all kinds of draw things on here. Right above program, do second function draw, and there's shade. If you did not find shade there, it's also under catalog, and catalog's right above the 0. You can find every keyword on the catalog or on the calculator in the catalog. But it's number 7. Pick shade, and then vars, right arrow over to y variables, function, pick y sub 2, comma, and then vars, y variables function, pick y sub 1, okay, and then comma. Then you tell it your x values. We want to go from 0 to 1, 0, comma, 1, comma. Then I'm telling it what kind of shading I want. 1 is vertical, and then comma, I'm going to tell it to skip every 5th pixel. Okay? And then press enter. Voila. Okay? If you want more lines, okay, let's go back. Second function quit. Let's do second function entry. And let's go back and do 3. Change that 5 to a 3. Just type over it. If you do second function entry, you don't have to type it all over again. Ooh, I didn't press enter. Hang on. And it should put some more vertical lines in there. If you choose to, if you made a mistake and say, hey, I need to clear that out, do second function draw, and there's clear draw on the first one, okay? And that will regraph it, okay, and make it clear. Let's try it. Clear the shading, and let's do a negative 45, okay? So do second function draw and clear draw. You might put that on there because it's under the draw menu, and maybe that for shade also, so you know where that comes from. Second function draw, and there is also a clear shade was number 7, right? And clear draw was like number 1, so that will clear the drawing. But then if you come back and go back to the home screen and then do second function entry, and we need to go back to the number 1 and make that a 3. And let's go like maybe 2 pixels, and then press enter. So you just see what that looks like. Okay. I'm going to take that back. If I go back to 3 pixels, oh, I need to clear it. Hang on. Clear the drawing, and then go back and do like clear out both those equations. Okay, now we're going to do another example. Okay, and say they ask you to find the area of the region between y squared equals 4x and the line 4x minus 3y equals 4. Okay? On both of these, you've got to solve for y. The author's not being nice on this one. So if you take the square root of this, and it's a squared, so you're going to have positive and negative. So on this one, and we're going to put it in y sub 1. If we take the square root of both sides here, in y sub 1, we're going to put in the square root of 4x. Okay? When you take the square root of both sides, you've got to consider positive or negative. I'm going to give you a window again. On this one, I want the x min to be negative 1, the x max to be 5, and scale 1. The y x min to be negative 2, x max to be 5, or excuse me, y max to be 5, and scale 1. So put in just that first equation, square root of 4x. And then the window, we want negative 1 to 5, scale 1, and we want negative 2 to 5, scale 1. Graph just that much, okay? And you should see okay, because this is a y to the second and an x to the first, and it's positive it opens to the right. Okay. Now you got to get the other half of that. To get the other half of that, you got to do the negative. You could say positive or negative. You could put in negative square root of 4x, but another way to say that is I just want what's the opposite in y sub 1. Okay, so go to y sub 2, get your cursor down on y sub 2, do negative, then do the vars key, right over the y variables function, and pick up y sub 1. Okay, and graph that. That should give you the other part. You're only going to see part of it down here on your window. Should give you the other part of your parabola. Okay? Everybody okay with that? Okay, now we've got to solve this one. Okay, if you solve this one, and I'm going to help you out. On this one, if I solve that in y sub 3, if I solve that for y, I'm going to put in 4/3 x minus 4/3. If I solved it for y, that's what I would get. Okay, so graph in y sub 3, parentheses 4 divided by 3, x minus 4 divided by 3. And I would put those fractions in parentheses. I would not use the 1.3333. Put it in as fraction. Okay, and then graph it. Okay, and notice it comes through something like this. Okay. Okay, now when you find the area between two curves, okay, everybody look up here a minute. When we did the vertical slices, I said up here, when we did the vertical slices, this was the top for every slice. This was the bottom curve for every slice. Okay, now, I'm okay doing that vertical, 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 until, don't put this down, watch. This is the top curve, this line is the bottom, until right over here. I'm in trouble because the bottom curve is the same as the top. Okay, so you have to look at your pictures and figure out, can I do vertical slices? On this one, the answer is no, because of that little area right here. That's not going to work. Okay, so instead of doing vertical slices, now you got to do horizontal slices. Hang on. Okay. I'll draw my picture back a minute. Okay, so we're going to do horizontal slices. Now you have to look at the horizontal slices. If I do horizontal slices on this, the line is on the right for every slice. This curve is on the left for every slice. Okay, so that's how you decide. Can I do vertical slices or do I have to do horizontal slices? Okay, if you do horizontal slices, then you have to integrate with respect to y. Okay, I would also label, let's label this curve. This one is the y equals 4x, or y squared equals 4x, sorry. And this curve is the 4x minus 3y equals 4. Notice back up here, when we integrated with vertical slices, okay, we had to use the x part of the ordered pair. Okay? When you integrate horizontal slices, use the y part of the ordered pair. So you have to figure out, where do these two intersect? Okay? Okay, find these 2 points of intersection. Take a minute and do that. Get this one? 4, 4 is right. For this one, I got like 1/4 or 0.25 -1. Okay. Okay, so we found the two ordered pairs. If you integrate with respect to y, use the y values. Now, I said it up above, and I didn't write it down. You may want to write it down. If you integrate with respect to x, use the x values of your ordered pair. If you integrate with respect to y, with horizontal slices, you use the y values of the ordered pair. Okay? So now, to integrate with respect to y, okay, you have to solve for x, okay? So you to integrate with respect to y, you got to solve for x. So you take your y squared equals 4x. You got to solve that equation for x. So divide by 4 on both sides. So you'd have y squared over 4 equals x. On the other one, you got 4x minus 3y equals 4. Divide by 4 on both sides. Oh, wait a minute. Hang on. I wrote that wrong. It was 4x minus 3y equals 4. First I added 3y. So I have 4x equals 4 plus 3y. And then divide by 4 on both sides. And x equals 3y plus 4 over 4. Okay? So now you can figure the area using the horizontal slices. It's the integral of, now which one goes first? Before it was the upper one, right? When we figured this, it was the upper one minus the lower one. Okay, on this one, when we're doing horizontal slices, it is the one on the right minus the one on the left. Okay, so the one on the right was the line. Okay, so that's this one. Okay, so we want 3y plus 4 over 4 minus the one on the left is y squared over 4, and that whole thing is with respect to y from, we're using the y values, so we're going from -1 to 4. So -1 to 4. Okay? Now, I would highlight the order makes a difference. It's the one on the right minus the one on the left. Okay? Okay. So, if we simplify this, we're going to have the area equals the definite integral from -1 to 4. These are like terms. Look, they're not like terms, that common denominator. You see the common denominator be 4 on the bottom? Make it easier, take that 4 out front. So it's take the 1/4 out front. Okay? Does that make sense? And then I'd have 3y plus 4 minus y squared with respect to y. That makes it so much easier getting rid of that fraction. Okay? So leave the 1/4 out front. Figure the antiderivative. Add 1 to this exponent and divide by the new exponent. So it's 3y squared over 2 plus. Okay, add 1 to the exponent, divide by the new exponent. And then add 1 to the exponent, divide by the exponent. And it's from -1 to 4. Okay. Leave the 1/4 out front. That's out in front of all of it. Okay. Now you're going to sub in the top number first. That whole thing, this is the f of b minus f of a. So now we have to do the bottom number. We got to do the -1. And then that whole thing's times 1/4. When you simplify this, you should get 16, 8, 24. 24 plus 16 minus 64 thirds. Simplify this one, we'd have 3 halves minus 4 plus 1/3. Got to keep track of the signs right here. Okay. then you'd have, if you simplify all that down, you get all the way down to 125 over 24, which is approximately 5 point, what is it, 125? 125 divided by 24. 5.208. Okay? 5.208. Go 3 decimal places. Okay? Okay. Now, we're going to add some of this to your card. Okay? We're going to add, I don't expect you to memorize all this. I expect you to be able to use it. Okay? Okay. I want you to put a, this is what mine looks like on my card. That little section right there. Okay? So you don't have to write too big. Okay? Area between curves. Okay? For vertical slices, we're going to separate it into vertical slices. The area equals the definite integral of f of x, it's f sub 1 of x, minus f sub 2 of x, that whole thing with respect to x from a to b. And I would put on there, you might put it in a different color, this is the upper curve minus the lower curve. Okay? So there's your one for vertical slices. Okay? Take a minute and add that one. It's the definite integral of f sub 1 of x minus f sub 2 of x with respect to x from a to b. Okay, then the other one is horizontal slices. And the only way you can tell is by looking at your graph and say, is the top, can I get everything where the top slice is one curve and the bottom slice is another curve? If not, then you have to go horizontal. Area equals the definite integral of f sub 1 of y minus f sub 2 of y, that whole thing with respect to y, and we're going to go from C to D. You sub in the top number first, you still sub in, and I would highlight this is the one on the right minus the one on the left. Okay. Okay, so that should finish that up. If your answer comes out in decimal form, make sure you round it to 3 decimal places. Okay.